What's up, fellow Minecraft enthusiasts? Today we are going to go over redstone logic circuits. So if you're interested, stick around and let's go through these one by one. XP. So let's start with the basics. A logic gate works on the principle, if this thing happens, then that thing happens. And you can see this with the most basic of all the logic gates that exists. You put a lever on a block and then put some redstone dust behind it and then put something like a piston. When you pull the lever, the piston goes up. And you can also create the next basic one, which is called the NOT gate. And the way that one works is the exact opposite. And then you lay down the same principle here, only when the lever is up, the piston is up. When the lever is down, the piston is down. It is the exact opposite of this, and that is why it's called a NOT gate. Building on the principles that we learned here with the basic input gate and the NOT gate, we can build what is called an AND gate. And what an AND gate does is it takes the input from two different sources and controls the output. And the way that's built is using two redstone torches that are connected, and then there's a NOT gate on the back of it. And we can connect it, and we can place a piston or something. And then now when we flip the switch, if one is on, nothing will happen. However, if I turn both off, then the piston gets activated. So this requires both to be in the off position, hence the term and. This and this need to be together. And then to build on this principle, we can actually build the inverted version of this called a NOT AND gate or a NAND gate. And the build that is similar in nature. We just do a lever with redstone torches, but this time we won't put the NOT gate on the back. And so this one will activate at all times when all of these are up. This one, the only time it will deactivate is when both are off. But it won't matter which one you flip, no matter what, it will stay on. Now these can be really useful for building access rooms and secret passageways. For example, you can have a lever in one part of your base and a lever in a different part of your base that is connected to redstone that will activate a door or a hidden staircase or something like that. Similarly, you can do something with this too. And in fact, you could switch it over to something like buttons that would require both buttons to be pressed together. This is really great for something like building a secret combinations or having two people press something at the same time. The next logic circuit we will talk about is called the OR gate. At its most basic, an OR gate takes input from two different sources and produces an output. And what an OR gate will do is it doesn't matter which one of these is toggled, it will activate the redstone or activate the piston. Hence the term OR. This can be either or, but it requires one of them to be activated. But it don't matter what I do with this one. And the opposite of that one is called a NOT OR a NOR gate. And that is done the same way, with the exception of we're going to place a redstone torch on the back of it to create the NOT version of this. And we can lay down redstone. And so at its most basic, no matter what, when the levers are up, the piston is up. When both of them are down, it's down. If either one of them are down, so it's a NOT OR gate. So it's the same principle as this one, just the opposite. Building on the principles of the OR gate, we're now going to learn about the XOR gate and the XNOR gate, also known as the exclusive OR gate and the exclusive NOR gate. Now the XOR gate, the way it works is if similar to an OR gate. However, one switch needs to be in the on position, the other one has to be in off position to work. Whereas this one here, one of them has to be in there. But if both of them are in the on or off position, you still got power. So to build the XOR gate, you build a T like so. You're going to go ahead and place your inputs on the front, just like this. Use a redstone torch, connect some redstone dust. Go ahead and place it like this. You're going to place a redstone torch here and the light will go out. Then you're going to come up here and you're going to place some stone like this. You're going to go ahead and connect these like this. And then go ahead and connect this with the torches. And that will be your output. And so this is the exclusive OR gate. So what will happen is if I switch one, piston will go up. But if I switch this one, it'll make the piston go down. So when the levers are both down, the piston is down. When both of them are up, the piston is down. It's exclusive to one or the other one. And now we're going to build the exact opposite of this one using a NOT gate at the end. And that will be called an exclusive NOR gate or an XNOR. And that one will only produce power when both levers are in the up or the down position. But if there is one that is up and the other one is down, it will not produce any signal. And to do that, you basically build the same thing as an XOR gate with levers. Place some redstone dust like so. You just build the same circuit, but at the very end, you're going to place a NOT gate at the end. It's important to learn these gates, especially the beginning ones. So now we have this, and we can go ahead and connect this like this, and then we're going to place a NOT gate here like so. And so when it has power, when both levers are up, like so. But if I turn one of these levers off, it doesn't matter which one, it will drop the piston, and the piston will go up again if both are down. So it is the exact opposite of the XOR gate. So in this case here, if any of the levers are up, or if they're both up, then the piston is up. If they're both down, the piston is also up. So it's the only way to drop it and lose power is to have one in the on or off position. And that concludes the basics of Redstone. And now we're going to go over how to use these and what instances you might want to use these. Here are some example situations where we can use some of these gates. For example, the basic input gate, I can connect a comparator to read the input signal of a chest. And so that when the chest is full, a light will come on to indicate, hey, this chest is full. The next one is the NOT gate. I have this light hooked up to a daylight sensor that is measuring the signal, and it's currently night in the game. So if I were to toggle to like daytime, let's see if time set day, it's going to turn the light off. And this is really helpful for having some automatic lights in your house. The next one is the AND gate. And so this is a safety mechanism if you wanted to make a trap. For example, if I turn this off and step on that pressure plate, it will activate that TNT over there. But if I leave that up, and I could walk across this pressure plate all day long by myself, but if I wanted to activate this as a trap for somebody to step across, it's going to trigger that and blow up for them. Pretty cool. And then there goes that build. All right, so the next one is the NAND gate. And so this one here, if I flip this switch, nothing happens. But if I place one item in this chest, it opens up a secret passageway. So it would need two different things to happen, the switch being pulled and the wooden sword or whatever you're putting in your chest to measure the signal. And the way that one was built was having a comparator on the back side just to measure a signal strength of 1. Basically, anything is placed in the chest. will trigger that to open or close. You could also have that as the opposite too. If like, you could have a trap built in the floor, and if you had, say, a stack of diamonds or something, let's just say you had a stack of lamps here, or a bunch of weapons or something like that that triggers, it would open a way down, maybe a trap that has somebody fall into because they took your diamonds or whatever, with a collection system at the bottom so that it picks the diamonds and stuff back up. Another example is having this OR switch here. So this one here, or it's a NOR, I believe. So this one here, I can flip the switch off and on, nothing happens. But the daylight sensor is triggered by having it day and night. So let me see here. Time set midnight. And that will trigger the light off. It would need both inputs to go off and on. And so that might be helpful for certain builds. Maybe, for example, to have this, different examples. The next one I have is something you would use in, it's an OR switch that is connected to two different daylight sensors with an observer going into them that will measure the tick of these daylight sensors. One is set to day and one is set to night. And then I have it set to a sugarcane farm so that it will grow. So if I change the day, time of day, time set, and let's just say sunrise. This redstone signal will trigger at every interval. So it makes for an automatic sugarcane farm. And it's using an OR so that it will work at nighttime and daytime, depending on your lighting and everything else. And this is an example of using an OR switch, being able to automatically farm materials, whether it would be bamboo or sugar. So these are just a few of the examples that you can use. And if you're interested in learning some more, please drop a comment and ask, and I can create some videos for that. And I appreciate it. Thank you again for watching, and we will see you guys on my next video. Have a good day.